Welcome to the Spoon Podcast, where we talk to the builders and makers on the front lines of the food tech revolution. I'm your host, Michael Wolf. On today's episode, we have Raj Singh, a longtime tech builder who first started exploring the intersection of AI, food, and how it could change food going back to the 2010s. And he's worked on lots of other software companies and lots of other verticals, and he sold his most recent company to Mozilla. And he came to CES to speak on one of our sessions, and I got to talking to him in the speaker ready room, asking him about what he saw and where he thinks AI is going, and it just made for a really fun conversation, so I thought it would also make for a fun podcast. So I hope you enjoy it. We have some really big news around podcasts, so make sure you tune in later in the week to hear about what we're working on. But for now, let's get to my conversation with Raj Singh. All right, I'm back from CES, and so is Raj Singh, who I'm glad to see you got back safely, Raj, although you did pick up a little bit of a cold. So thanks for joining us today.
Yeah, a little bit of a flu. My voice might be a little bit off, and I'm a little bit tired, but happy to be here to share what I saw.
I think we connected for the first time in California for our Food AI Summit, if I'm remembering correctly. And I got to know a little bit about you from your GPT Food Cam, which is a app that takes pictures of food, estimates calories. You could probably do a lot better job describing that.
Yeah, no, it was an arc that started in 9, but couldn't make it happen back then. The technology wasn't ready. But basically, you can take a photo of your food, and it gives you an estimate of the calories and sort of high-level macros. And it's really just trying to encourage this trend around healthier eating and being more aware.
And you, I think, wrote it because you were trying some of these other food tracking apps, food logging apps in the Apple App Store or wherever, and they just require so much work, so many clicks that, like, I've tried them before too. You basically abandon them because it's just too much work.
This might be deviating a bit, but very recently, or just yesterday or 2 days ago, I think Nikita launched the Explode app. I'm not sure if you saw that. Kind of went
No.
Semi-viral on Twitter, but it's basically trying to make Snapchat work over iMessage. And, he's had a couple consumer viral success. And I was talking to somebody internally. I work at Mozilla, my day job. I run a product called Solo. I was talking internally about, success factors in a consumer app. And, one is you need to have like a really thorough understanding of like consumer behavior. So like the Vice or whatever you're playing on. In this case, it's like be healthy. Like I care about my weight, my image, vanity. 2, you need to have obviously some form of distribution, whether it's like buy a ton of ads or influencer marketing or whatever it is. But 3, you have to have this like maniacal culture around UX and UI. Mm-hmm. And when we were designing, when I was thinking about GPT Food Cam, proverbial we, but I was like, wow, this is like so many clicks. Why hasn't anyone really tried to make this like less clicks? And so took some bold steps there. It opens straight to the camera, and then you just take a snap and then post the photo, and then boom, you have your estimate. And interestingly, it's the only app in the App Store that operates in that way. And so I think, there's a combination of things I think that create consumer success. So glad that it's out there and it's available. It's free and it uses AI, so it's really fun. And one of the interesting things that I did not anticipate was we still have a stickiness issue. We see people install it. They might try to stick with it for a few days, and they still, even the act of just taking a photo may still be too much work. However, we're finding people don't delete the app that often. Many of them are keeping it installed on their phone. They're almost using it like a utility, which is often how these things always play out. You build something and you see kind of things follow a different sort of track. So it's interesting to see people use it in that way. It's like, I have a ruler app on my phone. I have a GPT Food Cam app on my phone. Anytime I need to look up the calories or something, I can have it handy as like a little utility in the back pocket.
Yeah, I almost wonder if the usage occasions are not so much like every day, every meal occasion they're doing it, but more like, I'm eating out at Chili's. I've never had this gigantic salad before or whatever. Like I'm eating something new that I have no idea what the calorie count is. Or do you have a feel for what the usage occasion is?
Yeah, I think the intent early. So I think intent early on, it's a delightful. It's like, this is kind of cool. Let me go play with it.
Yeah, for sure.
There's a little bit of like, I want to show people. It's like, hey, check this out. Like, and that creates a little bit of a word of mouth. I call it WAMO, word of mouth. Well, not word of mouth optimization, but just word of mouth virality. I think, and then for some, it's like, hey, can I actually stick with this? And then they try for a few days. Now, the folks who manage to stick with MyFitnessPal, maybe 1% of the people who actually try the app. I mean, they're kind of a self-selected batch, and even them churn out after enough of a time horizon. And I think the same is true even in GPT Food Cam, at least so far. But I think the difference is people aren't necessarily deleting the app. They're keeping it on their phone because they're realizing, hey, I can use this in the random moments, I do need to look something up. And so that's really kind of neat. Ultimately, though, we should probably expect that the phones, the operating systems on the phones will just get smarter, and this will just be all built into the native camera.
Just another feature you could turn on in your phone, kind of the health lens, if you will.
Yeah, I mean, I sort of think of it like already you point your phone camera at a QR code and it kind of figures out it's a QR code. You can imagine at some point in the future, you open up your iOS camera and you just point at anything and click a button and it immediately moves into like object recognition mode and gives you data and details about everything you're looking at. And so you can imagine all these sorts of things, like which we have standalone apps for, like the ruler app, for example, all kind of getting replaced with just a single camera app.
Yeah, and I feel like we're in like, I don't know what wave of smart glasses. I mean, I remember going back to the Google glasses and watching the Robert Skibbles of the world walk around look like complete dorks. But like there was a certain number of those at CES this year where people are doing this swing at the smart glasses. And I think that makes a lot of sense as an app that'll just be built into, like, I can look at my food. It's going to tell me what the calorie count is. And you have all that little information on the sidebar.
Yeah. So the irony here is, I talked about how there was this arc in 2009 started as trying to build this sort of food calorie lookup tool using computer vision, really slow networks, poor cameras. There's a lot of things that were working against us, not just the tech, but the infrastructure. We pivoted into becoming a recipe company. And actually the recipe company was called All the Cooks, and it was one of the biggest communities on Android. We were actually a Google Glass launch app. So Sergey, during Google I/O keynote, actually demoed
your app.
Yeah, exactly. Yeah, All the Cooks, where basically, because that's always been one of those sort of like so-called true hands-free use cases. You're looking at your glasses, it kind of tells you what's the next step and whatnot because your hands are busy, you're making food, right? And so it's funny seeing that sort of full circle today, but very much in the camp that the new modality of autonomous glasses, or not autonomous glasses, just smart glasses, whatever you want to call them, are going to be a game changer. There was a lot of it at CES. I managed to try one or two pairs. There were lines.
What do you think? Where are we? How do you feel like this progress? Do you feel like we're making it close?
No, it was interesting. There was some stuff where it's kind of like up and to the right. So I would say it's a more refined version of the original Google Glass. So it just doesn't look as bulky, but effectively the same kind of sort of prism view up here at the right. There were one I looked at, I kind of wore, that honestly looked like it was a weekend hack project. And so that you get the wide range at CES, right? Like somebody just kind of pulled this together. There was another one that didn't really work, but what had crazy vision, this is what it's going to do, and this is what it's going to do. So obviously selling the future. I actually did stop by the Amazon hall as well.
Yep, I did too. Yep.
Yeah, they had their glasses. I tried that on. That's using Alexa. So they're basically, it's just voice. So there's no visual, but you can ask questions. So it's, so I was like, hey, Alexa, what's the weather here in Las Vegas today? And it was, I was impressed because it did handle the sort of outside noise cancellation pretty well. And they said it could handle, if there was a two-way conversation, you could maybe record or summarize the stream, things like that. The fact that it could isolate the voices. So I thought that was all very impressive.
Yeah, I mean, I'm not entirely sure I'm convinced like the voice is the interface to your glasses is going to be the interaction modality. I mean, I see obviously Amazon wants to do that, but we'll see where that goes. But stepping back and speaking more broadly of CES, I think you've been before, right? But you haven't been for a few years.
Yeah, I haven't been for a bit. I don't really do hardware. And so, it's if and when I'm at CES, it's always fun to kind of see what's coming because it's usually 5-year predictor of the future.
And you were there because I really wanted you to sit on one of our panels. We had a panel about the intersection of food and AI. And I wanted someone who's building something for the consumer space. We had some other speakers like Jasmine Hume working on next generation food using AI. But I always enjoy talking to you and kind of getting your perspective on where we are in kind of the AI evolution path. I think we can talk about some of the things you saw at CS, then maybe step back more broadly. So smart glasses were one, but what are some other things you saw walking around the floor of CS where you say, hey, this is interesting use of AI, or this is maybe something where they're talking about AI, but this isn't really AI?
Well, so, Jensen had this graph.
CEO of NVIDIA?
Yes, correct. That he displayed during his keynote where he talked about NVIDIA GPU demand and whatnot. And he drew this kind of curve. And he's basically said, the next step is agentic AI, coding copilots, whatnot. And that's all software, obviously. And then he said physical AI. And that's going to be where we're going to need tremendously more compute to train models for robotics and things like that. obviously being CES, it's all about physical AI. It's about robots, electronics, things like that. And so no surprise to anybody. Everybody's billboard, even when it almost didn't make sense, at some point mentioned AI somewhere in their language, marketing materials, collateral, whatnot. Walking through the halls, I saw a lot of stuff around autonomy. It was fascinating to see an autonomous garbage bin. I think those types of things are, very game-changing when you think about just sort of city planning. You can imagine in any neighborhood, you have one dumpster that just autonomously comes to your house on demand through your app. You throw your garbage out, and then it goes and parks itself again. And it kind of serves the neighborhood. I saw autonomous pool cleaning robots, autonomous lawnmowers. Yeah. I saw bird houses with computer vision. I even saw this Roomba alternative. It wasn't from Roomba, but a autonomous vacuum, but with a robotic arm on it, so it could pick up stuff and move it out of the way.
Yeah, move the sock or even gently nudge the pet out of the way.
Yeah, I'm not sure I buy it. Like some of these things feel a little gimmicky, like as a Roomba owner. But I think the company was called Roborock. I can't recall, but I think they're exploring these concepts, which I think in itself is just interesting. I saw an autonomous plant watering system for your home plants. That's a real problem. I mean, I have the problem in my house. I have a calendar reminder to go and water the plants, but if you could do something autonomously, that's great. So that was definitely one area where I just saw a lot of interesting stuff. There was also autonomous cars. No surprise there.
For sure, yeah.
Actually, probably the biggest standout thing, which I definitely took a few looks at, was this company called, I think it was called Xpeng. And they did this huge van that looked like it was at a T3, Terminator 3, with a helicopter in the trunk. I don't know if you saw that, but basically it's an autonomous minivan, very large minivan. Looks like one of those futuristic vehicles. And then they had a helicopter that was parked in the trunk that you could take out and it would unfold and then you could fly it. So that so-called last mile kind of solution. So really, really kind of fascinating, really out there, very crazy concepts. We talked about glasses. I also saw, there's a lot of stuff around medical devices.
Yeah. Yeah. There's the whole section on kind of future of health and digital health. Yep.
Yeah. We Things had this new scale that was kind of interesting with the mirror, and it was, they've done a good job. They were kind of first to market with their original scale before this whole quantified self kind of movement started, just simply tracking your weight. So I thought that was interesting. Most of the stuff though, within the medical devices section seemed either, like visionary, like sort of future, like where it's coming. Otherwise, it was really just derivatives of Apple Watch or other sort of.
Although I did see, I don't know if you saw this, a kiosk or a walk-up kiosk where you basically displaces or disintermediates the optometrist. It's essentially a digital kiosk that gets you your eyewear prescription. I thought last time I tried to get a new set of glasses prescriptions, I had a 3-month wait for my optometrist. So I just said, "I'll forget it. I'm going to walk up into Costco," and I use the Costco optometrist. But what if you could just use a machine? And it makes sense. And there was a big line of people getting their eyewear prescriptions.
I think that's a huge, that too. Yeah. There was also, I feel like there was a startup that was trying to do this as a attachment to an iPhone as well.
Oh yeah, that makes sense.
So you could just do it that way. But
it's kind of like makes sense. You're going from Warby Parker with your phone, sizing your glasses, to like judging what your next eye prescription should be.
Yeah, there's been attachments I've seen even for iPhones for doing, like if you want to do a 3D visualization of a space and you need a different kind of camera. But the general notion or theme I saw around the sort of medical devices section within CES was just pack in more sensors, new sensors coming. Can we track more interesting things? I thought that was all very sort of interesting.
So did you see any, because I noticed there was a half-day track on it, and I thought this was fascinating. There's a half-day track on kind of neural implants. And so this is the first time I've seen in any significant way that is a kind of a content track at CES. Were there any, I think there were a few startups doing essentially kind of the brain implant that Elon Musk, like chip in your brain as a technology at CES.
Yeah. I saw at least one. I didn't dig in. I was only there for 2 days, so I didn't really dig in to see what they were positioning or how it was being positioned differently. But the notion that it's it's like past the Overton window. It's like kind of like we're comfortable doing this now. Like let's implant the chip in our head. So I think I think that's all great. And I just read Neuralink announced that their third patient will be getting a device very soon, which is a big breakthrough. Another bucket was just gaming. There was just a ton of stuff around accessories to the MetaQuest VR headsets. Very clear that is the default developer VR platform. Is there any question about it? I mean, every single booth I was going to, people were using the MetaQuest.
So the MetaQuest is kind of where people are going for VR game development, essentially.
Yeah, or at least using it, at least these different vendors were using it to demonstrate their additional wearable device. Maybe it had some smart hand glove you wore. There's some fancy gloves. There was some fancy controllers or pucks or other things that you could wear or sit within or whatnot. But they were all building on top of using MetaQuest.
It's interesting that we haven't seen really. I mean, and I don't know if CES would be the venue for Apple's VR platform, but like it doesn't seem like that's gotten the traction people expected maybe a year or two ago.
Yeah, I think we have to wait and see what the reboot is. They haven't really.
It's still Apple, right? It was still Apple. You can't ever count them out.
Well, they didn't really position it for gaming. They kind of positioned it as it felt like it was productivity. Then it felt like it was an extension of your life. Then it felt a little bit like entertainment. I know Scoble was trying to use it 12 hours a day. You mentioned him earlier, just like the original Google Glass shower person. He was trying to use it 12 hours a day, but he did say after a few days he started getting, I think, some headaches. Like if I recall, it took him a while. I don't know
if you're old enough to remember Disclosure, the movie based. I forgot the book it was based on, but it was like Michael Douglas was in it, and it was a movie about virtual reality, and like he was walking around a virtual office. And so whenever I think of the Apple VR, like I think of like Disclosure, looking at my files in a VR headset was always seemed like a weird use case for me. But like it's
one of the things that's interesting here is there's kind of like, you swim upstream or you swim downstream, and what's the contrarian move? If you were just to look at CES, taking a step back, your perspective would be that the investment is going into glasses. So people are doing AR with a glass kind of form factor.
Augmented reality with kind of like, so a light overlay of some kind of an information layer versus full immersion with VR.
That would be your takeaway if you were at CES and just kind of looking at like sort of outside of the gaming section. That would be your sort of like, okay, based on walking the floor, this is what I'm seeing. So there's a question. The contrarian move here would be to say, no, I have strong conviction that there is a VR story outside of gaming. And I'm going to continue to invest down that path, or am I going to follow along with what I'm seeing the rest of the industry do, which is leave VR for gaming and go AR and look at the sort of glass sort of form factor. But that's definitely my read if you were just a layman walking through the floor.
I just feel like the applications for AR, augmented reality, are so much more, particularly if you look like professional applications like frontline workers in restaurants or firefighters, etc. It just seems like AR you can immediately put into enterprise applications and industrial applications versus VR is like, it definitely seems like, okay, there's entertainment, there's immersive environments, but like, what are the professional applications for that?
Yeah, well, I mean, so I think Zuck had mentioned this at the previous Facebook conference, maybe last year, not this year, the previous year. He basically talked about how they kind of accidentally landed in a successful position in a funny way. He basically said, we invested all this money, build in AR VR, and then we figured out like, oh, the use case was right there in front of us. We have these large language models. Now you're wearing your glasses and you can just ask questions about what you're looking at. And, a good demonstration of that, if you haven't played with it, is Google AI Studio Live. So people can search offline and try it, but basically open your camera, walk around, and as it's seeing things, you can ask questions about what it's seeing through your phone camera, through the browser. And you should imagine, or we should expect, that assuming we can solve the battery life thing. So this is where we need the Enron egg, which was their little spoof thing they announced at CES, which was basically your take-home nuclear reactor. But this is where if we can solve the battery life issue, you can very much expect you're wearing your glasses, and anytime you're walking around anywhere in the house, whatnot, you can just query for anything. You can say, show me my calendar using voice, and then boom, it pops up. And we do know, I know you mentioned earlier some reservations around voice as an interface. However, even in the sort of Siri kind of data, voice is still mostly used at home, in closed environments, and in the car.
Yeah.
And so you will use it in that way. And then you can imagine if you're out and about, going on a hike, wearing your shades, and you see a tree or see a park, you see a
Makes a lot of
landmark,
sense.
whatever, you're going to ask questions using voice. You want to pull your phone out.
It makes perfect
It's much
sense.
more-
Yeah.
Yeah.
I just still have the second party, third party cringe of people walking through the airport with their Bluetooth headsets and talking loudly on a conference call. Like, I just don't want to be that guy using Alexa in an airport. But I guess the usage cases you're talking about just make so much sense. I think at home, people who have need for assistance and just walking on hikes, that just makes so much sense to me.
Yeah, I mean, I think I agree. You don't want to be that person who's like, like having full-blown conversations, but I imagine it's going to be more transactional type queries and questions.
Yeah, I agree.
And you're mostly going to be listening as opposed to, or seeing as opposed to speaking. Whether it's going to create a new form of distracted driving, distracted walking, distracted biking, I don't know. That's a whole different question. But I think it's really exciting tech because we haven't had a new modality in a long time.
We talked a little bit about in the speaker room when you're back there with me getting ready for the panel about the next wave of AI. And you mentioned a little bit about the CEO of NVIDIA talking about agentic AI, et cetera, but you had some other ideas about what are some models. I think for the layman who's kind of just been a smart person reading newspapers or whatever they do nowadays to find, they know about large language models. Okay, we get ChatGPT. And I think maybe some people have read about, okay, agents are becoming a thing, co-pilots, but what's on the horizon for people who aren't AI all day, everything, who aren't like you building AI products? What should people be aware of over the next couple of years? What are the things that are coming down the pipeline?
Yeah. So, it's funny when Siri was acquired by Apple, a lot of people haven't actually played with Siri before it was acquired by Apple.
Yeah.
Before it was acquired by Apple, it was not a ask a question, get an answer. It was do a task. It'd be like, book me a flight to New York on Saturday at 3. And it'd be like, okay, we will complete that task for you, right? It'll be like, make me a reservation for X, Y, and Z. And then when Apple relaunched Siri, they stripped away all of its sort of task completion ability and turned it into very much more of a question and answer kind of system. Just ask questions, it'll give you answers. Right now, this sort of first generation, let's say call it ChatGPT, just using that as an example, but there's many, many choices here. People are mostly using it to gather information. It's multimodal input. You can obviously type in your question, you could speak your question, you could upload an image, you could show live video, and you get an answer and it gives you an answer back. The next step, which is starting to happen, is they're making it multimodal output. So for example, you can ask a question and you get an image back instead of text back. Well, the question is, why does it have to be an image? Why can't it actually give me a pivot table or maybe give me a whole web page? Because what I'm asking for requires something that can't really be rendered well in just a paragraph of text, or give me a file or give me an app, because maybe I'm asking you a question and it's best for you to display what I'm asking for as a calculator app, right? And so you can imagine we have multimodal input, we're going to have multimodal output. Then sort of the next step after that is like, well, hey, do tasks for me, right? So you saw ChatGPT, or you may have seen ChatGPT just a few days ago, but this has all been in the works and it's not original. Now let you set calendar reminders. So you can tell ChatGPT on every Friday morning at 9 a.m., please answer this prompt and send me an email or whatnot, right? And so you could basically say, hey, run a search on Google for these keywords and summarize all the articles that you find against those keywords, because that's my competitive analysis, and send me that email summary every Friday morning, right? And so now it's starting to do tasks. And that could go a step further, like now book me the flight, book me the reservation, write me the email, set up my meetings, set up my appointments, call the doctor, whatnot. So you can see kind of that's sort of the next step where we're going. And some people have called that language action models as opposed to large language models, so LAMs. But the challenge right now is we have a lot of data for sort of like, basically the internet for answering questions, but we don't have a lot of data of people doing tasks. And so a lot of that data is being collected and created now. So it's being recorded, like, show me somebody, filling out their Excel 50 times, right? So like just doing these activities over and over again. Yeah. Right. And they're building those data sets. And you can imagine in these next versions of these models, and again, these are not like singular. This is not a singular problem. These are like hundreds of little problems, and we have to solve each of them kind of independently. But you can see they're starting to tackle as they build more of these training data sets. This is sort of our pathway to AGI, right? And we obviously want to get to a point in the kind of the end game here,
which is for people who don't know, like just general. It's kind of the holy grail for AI. It's kind of
artificial
generalized intelligence. Yeah.
Correct. Yeah, and ultimately where you want to get to is even when you're dealing with robotics. How do robots learn? They should learn by mimicking human behavior. So if I want to teach a robot how to wash the dishes, if I was to give it a data set of a human washing the dishes 50,000 times, and it's a high quality data set, so it's like, video footage that's clear and they have, different camera angles and whatnot, that a robot can then learn and then do the same work themselves, right? And so that's where we're going. And so right now there's a lot of work being done and money being spent by massive companies on creating these data sets through human labelers. That's why you have other billion-dollar companies like Scale.ai that just sort of do that, as well as synthetic data sets, which are just basically machine-created data sets that are being used to try to tackle these more specific use cases.
I don't think these things are disconnected, right? But as we see the rise of things like smart glasses that are walking around with people through their physical worlds and possibly maybe gathering data. So if I want to gather data about what I do for a living or what my walking through New York City looks like, or just in my house, can we gather data using these types of input devices to build the models for essentially the physical AI that NVIDIA is talking about?
Yeah, exactly. Right. Yeah. So, they call this in building a model, there's different phases. And the first phase is called pre-training. And pre-training is where you basically give it all the data kind of raw. Here's all the data of the internet. Like here's all the text. If you read a bunch of books, you learn a certain amount of things, but actually a video of something contains a lot of data too. So if you give a machine all the YouTube videos, it can learn a lot from those YouTube videos. It can start getting an understanding of physics. It could see like, oh, interesting. In all these videos, things fall like this and things move like this and plants sway like this and wind blows like this and things like that, right? And so there's tons of data that it can extract from during this pre-training sort of phase, irrespective of modality, audio, video, text, whatever, right? Then the sort of next step is you want to fine tune the model training workflow, right? The fine tuning process, you usually want to use higher quality annotated data. And so this is where you use humans to go and take specific tasks and build data in a way that's easy for a computer to understand. So let me explain that because that might be a little bit confusing. If I just asked somebody, hey, I need to train my machine on math. I need to train my model on math. And I write down like 2 + 2 and you write 4 and somebody else. For a computer, that's like, oh, okay, 2 + 2 = 4. That's okay, but it's better if you wrote it out 2 + 2 = 4 and you actually drew like, here's two things, circle, circle. Like you're trying to teach it the math. That's a high quality data set. That's like you're writing the data in a way to make the computer learn better, right? And so the next step after the pre-training step, during the fine-tuning step, use tens of thousands of examples of these high quality annotated data for each of these kinds of use cases and different things. And then you fine tune and train with that. And then that gives you an even better sort of result. So full circle to your original question, the video, yes, we can take all the video in the world. There's a certain point at which it may not really move the needle. But the next step is they're still going to need high quality video that involves humans creating in a way to make it easy for computers to understand.
Yeah, it's a really interesting time, and it seems like the next big wave is going to be understanding the physical world we live in and kind of building the data around that rather than just all the information on the internet, et cetera. And I guess what you're saying is a lot of the training is probably going to happen with like the massive video, et cetera. I think I remember I wrote a story last year about, which is 2024, about how Google was training its robots by just taking a video, walking through a space, and then it would just feed this video, and then the robot would understand where to go and then deliver food, for example, just by one walkthrough of a video. So it feels like that is going to be a big kind of way to train these robots in the future.
Yeah, I mean, 100%, right? I mean, so I don't know if you saw the whole AlphaZero story with chess and how it played against itself over and over again to kind of build a model. So I think, that's a good example of using synthetic data. But um, I think I'm not the subject matter expert on this, so I don't want to misspeak, because there's going to be listeners here who are 100 times more researchers in this space, and they're probably laughing at some of the stuff I'm saying. But the sort of 10,000 foot view, the TLDR here is there's a lot of opportunity to collect and annotate more data, create more high quality data, and these additional data sources, as we train and fine tune against them, they're going to start addressing gaps in our models, and these models will then continue to get better and better. And we're already seeing it. I mean, just the pace of improvement every few months. I mean, the fact that ChatGPT does math perfectly well now. The other thing I think people don't realize—
it does recipes pretty good too now. It used to not do good recipes.
I think the other thing too that people don't realize is, they're using a lot of tricks that may not even be obvious. For example, when you ask a question, they may not just send it right to their large language model. They might first figure out, oh, what is your question about? Oh, your question is about this. You're asking about the weather. Oh, that's not something I can answer. I need to write some code, or I need to figure out who's the API provider for that. Oh, let me write some code to get the weather for you. Oh, let me go run that code in a sandbox. So it's figuring out like, oh, this is a deterministic request. I shouldn't run this through my model, or this is more of a stochastic, like a probabilistic request. I should run this through my model. And so the fact that they're doing this pre-processing, even when you ask the query through ChatGPT, and then when you get the output, they're then running it through post-processing. They're like, oh, here's the result, but am I displaying it in the best way for this person to understand? Should it be presented in a different modality? Should it be presented as an image, or should it be presented as a graph, right? And so they're using a bunch of little techniques and tactics around the edges. And I find it all very interesting, because if you look at Moore's law, like Moore's law originally was based on transistors, like how many transistors can we pack on a wafer? And that was sort of the benchmark on like, here's the 18-month rule, like we're going to double every 18 months because we can double the number of transistors on a wafer. Well, it turned out a lot of the gains in Moore's law didn't come because we necessarily doubled the number of transistors on the wafer, but rather we made all these other architectural improvements around the wafer, right? Like the speed of the different pipes and the things around it and all that, and the architecture, et cetera. And the same thing is true here. We're able to exact more out of these models by fixing different parts of other things around it. And if you look at OpenAI's most recent reasoning models, like O1 and O3, interestingly, they're both based on GPT-4, which is to imply that they're really just GPT-4 models underneath. But then what they're doing differently is when you ask a query using the OpenAI O1, the GPT-4, the O1 model, it's basically taking your question, and they put a bunch of prompting around to say, hey, break down his question into a series of other questions and a series of steps, and then go and query each of those separately, and then go and discuss amongst each other like a series of agents. So I can talk about what an agentic structure looks like, but that's how they work. I can break it down if we have time. And then keep doing this over and over again, and then it'll yield a better result. So interestingly, it's the same model getting a better result, but by allowing it to basically search more paths, more possible answers. So imagine I ask, what are your thoughts on this problem? And it goes, okay, so internally it goes, how would I solve this? Okay, let me, the first step is I would do this. Okay, let me go do this first step. Now let me get 10 other options. And let me now go down each of those paths. Now let me go down each of those paths. And then at the end, let me go summarize all of those back into one answer. Yeah. Right. And so that's so you're getting improvement just by making adjustments to the prompting strategies. And that's why they're calling it a reasoning model.
To use your analogy of the computer, it's like the old kind of Dell laptop. You have your Pentium, and then to get the next generation computer, it's just adding more memory and all the things around it that just makes the performance go faster, essentially.
Yeah, no, that's actually probably even a better example. Like there was a time when it used to be just megahertz, but everyone knew like you could have like the most
more memory, bigger hard drives, etc. Faster.
Yeah, you had all the megahertz, but you only had 2 megs of RAM, and it doesn't matter. It was going to fail, right? So like you needed, like it was going to be slow, right? So it's interesting watching all of this, and actually it's basically created a new discussion. They call it inference time compute. I don't know if that's a term you're familiar with, but
Mm-mm.
all the discussion right now has been around, do we have enough computational power for training? But the processing that's used to actually answer the query, that part answering the query is called inference. It's a different kind of architecture. And so there's a different set of chipset companies out there that are building LPUs, language processing units, companies like Grok, not Twitter Grok, the other Grok, Cerebras, others that are trying to optimize on being really fast at answering queries. That's so inference time. And people are now saying the challenge is not on training time. The challenge is now on inference time, because we have these queries doing these reasonings. They're running all these subqueries, and we don't have enough compute to answer your question fast enough, because you want instant answer like Google.
It's fascinating. Like anyone who followed the old Silicon Valley and kind of when the desktop computer was like the main thing, there's a whole set of new players that are kind of just providing solutions to kind of get the ball to move forward. I could talk about you all day. I could talk this about you all day. Let me see. I'm going to edit this out. I could talk about this all day with you, but I just wanted people to know real quickly a little bit about yourself. How did you get into becoming like a guy who writes his own apps using AI, building companies that you sell to Mozilla? You built an app that was on the stage with the demo of Google Glass. How did you get into all this?
I was in college. I saw the dot-com boom happening, and I was like, I can't miss this. It's like 1998, 99. I teamed up with some of my college friends, and we said, we have to build something. I mean, we got to turn down our summer internship and build something. And that's kind of when it started. We built a meta file sharing network. So that was like the Napster era, but we were the first. Yeah, we were the first.
Kazaa and all those.
Yeah, exactly. Sorry about that. Yeah, and that's kind of where it started. And then basically I haven't looked back. So I've been mostly just been building stuff on my own since then. And I've definitely had my share of failures, but I've had some success too. Last company was acquired by Mozilla. Previous company acquired by Salesforce. I tend to follow my passion, so it's always areas of interest is where I build, but that's kind of been my path. I guess I love tech.
When you went to college, were you a math major or a computer science major? What were you going to college for?
So I went for computer engineering. So at the time, and things have changed now, but at the time, they had computer science and they had electrical engineering. And then computer engineering was kind of in between computer science, program, basically software development and electrical engineering. Computer science at the time in college was not as much development as it was algorithms. And so it was much more about things like they call big O notation, which is like algorithm efficiency, things like that. It was more theoretical. I think in 2003, 2004, 2005, they introduced software engineering as a major, which definitely would have been my preferred major of choice, but they didn't have that at the time because it was kind of a new and nascent sort of industry. I don't know what it looks like today, but what's wild now is with all the no-code development tools, you can get pretty far with very little coding knowledge, which is quite amazing. I still think you need some knowledge, and it's still very hard to do the last mile. You kind of get stuck in these loops and things like that, but you can kind of see where it's going. And you can imagine a lot of these are called CRUD apps, basically create a record, update a record, delete a record, very simple. If you're thinking about like very simple types of apps, like a web page that has a form, an intake form that you submit and then send somewhere or whatnot, those types of things you should be able to start building on your own. And so that's why you're seeing some really interesting things happening in SaaS now, because there's this big movement towards, should we buy or should we just build internally? Because we're paying a lot per seat, but we're only using 5% of this SaaS product. And can we replicate that internally and build more quickly using no code development?
So the HubSpots and Salesforces of the world, are they in trouble?
But there is a cohort within Silicon Valley that is very much in that camp. I think Chamath on the All In podcast is always talking about it. He has a company project called, I think it's called like 80/20, or I forget what it's called, but basically his thesis is like, 80% of the workflow for 20% of the cost or something like that. But the general notion is that if I just need a lot of these, some of these tools are, if you're just using it out of box, they're just simple forms and they're systems of records. Why do you need to spend so much? Now, the reality is if you're a larger organization, you're building so much customization on top of that, custom workflows, custom setups, things like that, that it may not be so easy to just sort of migrate off. it is all very scary to see how this all plays out and how this may or may not impact SaaS going forward.
Well, Raj Singh, I always enjoy talking to you. Where can people find out more about you?
Yeah, LinkedIn or my Linktree. Welcome to look me up there. My Linktree has a list of products I've built over my career. Either way works great. Or you can reach me on @MobileRaj. I'm pretty much I'm on all of them: Threads, Blue Sky, Twitter.
All right. Thanks, Raj.
Thank you.
I hope you enjoyed my conversation with Raj Singh as we talked about what we saw at CES and the evolution path of AI. If you haven't already, please rate and review the podcast in Apple Podcasts or Spotify. It really does help. And on the way out, enjoy this AI-generated new wave tune about CES.
Bright lights in the Vegas night. CES is shining so bright. Gadgets flashing in neon schemes. Tech dreams become living dreams. Robots roam these endless aisles. Their gentle wizards trade their smiles. AI whispers in our ears. Future speaking beyond our fears. We're living in a sci-fi scene. Ruling like a digital queen. There's more flashing neon green. In this tech world, we reign supreme. Virtual screens, they pull us in. Binary codes where magic begins.